Hi, welcome to our demo, Enabling Telco Cloud and Edge with CAMARA APIs. This demo was done in collaboration with Intel Network Builders. We are happy to work with them on this project as well as past Intel test beds. Today, we're going to focus on enabling developer-centric networking with CAMARA APIs. So, as many of you are aware, CAMARA APIs expose network data and controls so developers can build network-aware business apps that dynamically and continuously optimize latency, bandwidth, and resources. The telecom industry is defining CAMARA APIs for discrete use cases, but there is no common model or shared library to support their implementations. So EnterpriseWeb provides a declarative abstraction across a set of CAMARA APIs, along with integration services, in order to provide a consistent developer experience, to simplify and automate developer tasks, and to centralize management. It's CAMARA APIs enabled. The key here is for the industry to have CAMARA API adoption, to build communities of developers, they're going to need to make it easy for developers to participate. Another thing they're going to have to do is make it secure. So part two of this demo is securing developer-centric networking with CAMARA APIs. Exposing network data and controls to the developer community opens the network to a new set of exploits. There is no standard security model for CAMARA APIs either. There's no security standard that covers the end-to-end scope of the interfaces. So in this demo, you're going to see the EnterpriseWeb integrated solution with endpoint to infrastructure security closes the gaps to protect both the business applications and the telco networks. In particular, we're working with Intel Trust Domain Extensions, Intel TDX, which assures security of data in motion, data at rest, and importantly, in memory. Fortinet is providing its FortiWeb product, which provides an application security, and FortiGate provides next generation firewalls. So now we get CAMARA APIs secured. In the demo, you're going to see how EnterpriseWeb acts as a unified platform for CAMARA APIs. At the heart of EnterpriseWeb's platform is a harmonized, standards-based telecom domain model that includes not only the CAMARA APIs, but also includes 3GPP concepts, Open RAN concepts, TMF Open APIs, ETSI NFV concepts, as well as MEF-LSO and Open Group Tosca concepts. So that model provides common domain semantics and metadata, as well as state information, to help automate the end-to-end service development lifecycle. The use case for today's demo is a computer vision scenario. It's security cameras at, let's say, a factory or a warehouse or a port or any other kind of enterprise campus, etc. And they're going to be connecting over a 5G network. The computer vision is going to detect some people moving in the field of view, and it's going to then request additional resources so that it can scale up for higher resolution. And then it's going to, when the object is no longer in the view, it's going to scale itself back down. So it's essentially a closed loop from the edge perspective. The edge is actually controlling the consumption of the resources. It's not only a network aware application, it's an application centric. The application is driving the consumption of network resources and infrastructure. So I'm going to pass that to you, Bill. You take it away from here.
Thanks, Dave. Now I'm going to go through the demo for you, but I'm going to do it 2 times. I'm going to do it once as a developer and show you just how easy the platform makes it for me to be able to deliver this application the way I want on a telco cloud, leveraging the power of CAMARA and so on. And then I'll go back through it again and I'll touch on how the graph actually supports all the power that you're seeing. Okay, so I'm starting as a developer at day 0 onboarding. I have an application package that's been provided to me. In this case, it was a zip file that contains things like scripts, inventories, Docker images, and so on. I'd like to onboard that into EnterpriseWeb Platform and start using it to actually compose my application. So let's go ahead and do that. I'm using the Application Manager, one of the modules in EnterpriseWeb that's used for managing such code packages. You can see a catalog here of things that have already been onboarded. I want to add my application to this catalog, so let's go ahead and use GenAI to make that process a little bit faster. Onboard a new application called My Security App from a zip file. So the system's already identified that it's a security monitoring app. I can go ahead and confirm that, and the system will complete any of the rest of the mappings that I need.
Please use the report shown to fix the errors found during import.
So the platform's already mapped my application into the model that you're seeing here, and it's actually at this point driving me to finish validating that object. There's a couple of missing items that it's telling me about, and it will take me directly to where I can fix those. Just to note though, the system did map all the properties and generate all the interfaces needed for this app. And as a developer, I would typically sort of leaf through these, just make sure they generally align. Things like video streams are externalized as attributes that I can fix. Things like the sort of policy parameters are already set in most cases here. This all looks good as far as what I'm concerned with my application. And if I look at the interfaces, I'll actually see that it generated a bunch of standards-based interfaces, MEF, etc., and so on. But most importantly, the ones related to CAMARA from the Linux Foundation GSMA. I can see that Edge Cloud, Connectivity Insights, and Quality on Demand are all here per what I'd expect. And if I wanted to, I could go and follow the reference documentation and so on, make sure they're in the sort of in the format that I'm looking for. Since they match up, all I'm going to do now is complete the validation of my package or my onboarding. So I can just click on one of these links. It'll take me directly to where I need to make the changes. And you can see it's actually identified the couple here. So I'll just go ahead and do those. It needed a new registry mapping. It needed me to change, this is actually me just determining that I might like a different deployment type for this app. And then it needed a policy for the CAMARA request API. Basically, I'd like a closed loop between APIs in CAMARA. I don't want to code any of that manually or anything like that. I just want to specify it here as a policy and let the system implement it.
The application is ready for testing.
Start DevSecOps testing. Now the system is already actually standing up. We can take a look at this really quickly, but there's a trace here that's actually telling me what's happening during this testing, which is that a DMZ is being stood up in an OpenShift instance. There's a number of tests that are all sort of per my DevSecOps testing pipeline
The
that are in place.
application has been published to the catalog.
And now that it's passed, if I want to, I can review any of those results. I'll see that each one of the individual tests passed, and then it even removed the instance. And with that, since it's in our catalog, we can proceed to actual composition. So for composition, I'm going to use our Service Manager component, and I'm going to lean on GenAI to make this process really simple and fast. Show me a list of service templates.
Working on it.
Show me the graph of a hosted 5G app.
Working on it.
Add a firewall.
Working on it.
Add a security monitoring app.
Working on it.
Can I compose this?
Yes, all required elements are in the catalog.
Execute command compose network service template.
To do this, I will create a new network service template named Security Monitoring. Configure the service to work with hosted RAN and core functions. Add an instance of my security app to provide the security monitoring, and add an instance of Fortinet to provide the firewall. Would you like me to proceed?
Yes.
Okay, working on it.
Okay, now the app's been actually composed into a service for me. I can see that there's going to be elements that will be hosted and supplied by the actual provider, such as the RAN and core. I can see my firewall. I can look at this service graph that's actually been composed here. I can go through additional details such as the properties that have been mapped, and again, they match up with what we'd set up earlier, including that policy for the closed loop that I wanted to have in place for CAMARA use. I can look at the deployment plan that the system generated, and this is one of the places where I would actually look as a developer. I can look at it as a flowchart if I want to see that the general application deployment is what I expect. And if I wanted to, I might customize this and actually add additional tasks if I have some specific need, like for instance, maybe updating a specific inventory and so on. But if it matches what I want as a developer, I'm pretty happy. I can go ahead and actually validate this, and just like before, it will end up in my catalog.
The service has been published to the catalog.
So since it passed validation, I can now go ahead and actually start deploying it. So now I'm on to deployment. I have a look at my catalog here. I can filter it to a specific type, for instance, the services that are there. I see my security monitoring service that I just composed, and I can order an instance very easily. I'm going to specify which telco cloud I want, and the system has already just determined what the sort of available ones are. I want the one with TDX and the secure computing. I'll go ahead and actually add a video stream here, maybe 2, for the application to actually monitor. And I'll go ahead and deploy. So I can see that here in my inventory that it's actually being deployed. It's allocating resources and so on right now. If I wanted to, I could actually take a look at that telco cloud. And let's do that quickly here. So in Azure, we have that instance of the telco cloud. And I'll see that my individual elements related to my application are now being stood up. Back inside EnterpriseWeb, I can see that it's now marked as healthy. I can take a look at the details, which are going to include that day one order and all the details related to it. So I can take a look at the trace as a developer and see what it did. I can filter this to the components that I might be, I might care most about. For instance, if I want to see just what the CAMARA API calls were, I can filter to those. I can trace down to specific elements, for instance. If I want to see what was related to the Fortinet firewall that was in place, I can filter just to those. So I can get an idea of exactly what the system did in the deployment workflow for any sort of any area that I might want to focus on as a developer. I can drill down to more detail. I can look at the deployment graph of what was stood up, the fact that TDX security is actually available on that host. I can even look at the health of the individual VDUs. I can drill into the deployed applications and take a look at what's happening. Remember, this is a computer vision application, so I can actually pop into one of the nodes. And what I'll be able to see here is that in real time, it's actually monitoring a feed. It's identifying that a person is there. And as a result, the application has a bunch of day 2 events that are occurring. So let's go ahead and actually look at that. And you can see that in a couple of these cases, it's actually, it's detected an object. So this is an indication that the system is actually working as intended. If I look at the trace, I can see what it's doing as a result, which is effectively going from the fact that an object was detected in frame to going back to CAMARA to request additional resources and even updating the security in relation to that. So that's an end-to-end developer experience for deploying this application. I talked quite a bit, but you can see the actual work that was required was quite minimal. It was all powered by the graph that's behind this. So I'm going to now redo the demo for you and drive a little bit deeper into how the graph helped us at each step. Here we see the harmonized model. This is much bigger than just the CAMARA APIs. This is a harmonized model of the entire telco domain, providing the shared metadata state and relationships for day 0, day 1, and day 2. So now I return to day 0 onboarding, and it's just important to note before I even start the process that everything that you actually see in this demo, meaning the UI itself, the GenAI interactions, are all also powered by that graph in addition to the application delivery itself. So let's go ahead and again bootstrap the process using GenAI. Onboard a new application called My Security App from a zip file. So I upload the package, but it's important to note that even at this point, the system has already gone through based on my voice command and understands the types of packages that can be accepted, the difference between zips and tars and so on. So it's really setting the stage for the onboarding process itself right from the outset. As soon as I upload that package, as we mentioned before, the system is doing entity extraction and algorithmic mapping. It's quite literally taking all the artifacts that were in that package, matching them to the graph and giving me a confidence score on what type we might be working with.
Please use the report shown to fix the errors found during import.
Now, last time we were sort of concentrating on the developer experience, so we went almost straight to correcting these errors. And of course, these come directly out of the graph. It matching the type that we'd set up earlier, and then looking at the artifacts, it was able to determine There was links to things like CAMARA APIs inside of those artifacts, that things like a registry might not have been set. All that comes from sort of two places. One is the graph that's being constructed behind the scenes for this particular object. So this is a local graph of the object that we're talking about. You can see all the different elements of it. You can actually look at the sort of application-specific components. You can see things like high-res and low-res feeds that are related to the app itself. Then you can even see the CAMARA APIs up here. And then there's a lot of other details in terms of how it's deployed. But this graph is, for this particular object, is always being maintained based on the choices that we make inside the UI. And it's really the thing that's sort of being reflected in terms of the set of models that are bound to this object, the properties that are extracted and going to be mapped, and even the interfaces as we saw before. So that's what leads to the system being able to bind an interface like, say, the Edge Cloud CAMARA interface, and the system being able to generate an entire implementation behind it without anyone having to write a single line of code. We could continue on with the onboarding process, but what we'll do is skip ahead to composition so we can look at some of the graph aspects there. Composing a service through GenAI is a good example where you can see the graph come into play pretty much explicitly. Show me a list of service templates.
Working on it.
Each of these service types come directly from the graph, and when I select one, the system is actually going to have a lot of information about what the kinds of components are that are behind it. Show me the graph of a hosted 5G app.
Working on it.
So this graph in particular, the system will know that the 5G core and RAN are going to come from the host. I don't need to add them in any way. I'm now effectively just building up what additional applications I want to run at that edge. And then the system will go ahead and look at the graph, look at the catalog and so on, and tell me if I'm actually able to build the graph that I'm sort of requesting here. Add a firewall.
Working on it.
Add a security monitoring app.
Working on it.
Can I compose this?
Yes, all required elements are in the catalog.
Execute command compose network service template.
To do this, I will create a new network service template named security monitoring. Configure the service to work with hosted RAN and core functions. Add an instance of my security app to provide the security monitoring, and add an instance of Fortinet to provide the firewall. Would you like me to proceed?
Now this is an example where the system not only took a look at the graph, but also bound it to specific elements from our catalog. Since it is what we want, we'll go ahead and actually create the service just like before. And here we see the service graph has just bound those elements. The ones that come from the hosted environment have no configuration as expected. Things like affinities and so on will be bound to the elements we can configure. And then our graph is actually built up. And as before, the system has even created a deployment plan, which is itself a graph. So a directed acyclic graph, basically a state chart based logic driven process that connects these high level elements as a data flow. We can take a look at that even being simulated in the system, and so on. But we use graph here to make the composition very easy, as you saw. Let's jump ahead to deployment and take a quick look at that. So I added that service to the catalog. Now as I place an order for it, at the point of deployment, you'll see that the system's already kicking in information from the graph. It's actually looked at all the available hosts and narrowed them down to the requirements of this particular service. It needed to have CAMARA, and it even identified where TDX and secure computing would be available. We can then go ahead and proceed with deploying. Finally, once the service is deployed, we see an instance here in inventory, which is really an aggregate of all of the graphs related to the deployment. So when we look at the life cycle, we see day 1 and day 2 events, all again mapped and implemented by the system with zero code. We see things related to the application, like the HD feeds that we mentioned earlier in the graph that was constructed for the application. And then we even see scaling events and so on, which are keeping this thing optimized through its life cycle. Drilling into any one of these, we see again the power of the graph behind it, that every lower level task that was implemented, not only did the system build that from one of our deployment workflows, that high level state chart that we saw earlier, binding it to specific elements, but of course that's then filterable based on the tags that were in the graph. It supports things like day 1, day 2, day 3, L0 to L1, and the particular domain. So we can, that's the reason why we're able to very easily focus in on something like CAMARA APIs. And then finally, if we even wanted to, we can look at the deployment graph itself that's being continuously maintained by the system, tell us effectively where this thing is deployed, what kinds of services are available and weave to it, and this graph will grow if the service scales, for instance, and so on. So in summary, we went through the developer experience and saw how the platform makes it really easy for someone to implement over CAMARA APIs and effectively realize the service they want on the Telco cloud. Then we revisited the process from the lens of the graph and showed where the power of our platform came from. Thank you very much. Back to you, Dave.
That was great, Bill. Thanks. And to everybody attending, thank you for your time and interest. We really appreciate it. If you want more information, you want to schedule a remote demo or meet us in person in Barcelona at MWC24, please contact me at dave@enterpriseweb.com. Before we go, I want to give a shout out to our friends at Intel, Peter Torre, Wally Botter, Daphne Chen, Mark Weir. Thank you so much for all your support. We really appreciate it. Also to our other partners, Microsoft and KX, which contributed to the generative AI and natural language programming interface, as well as Fortinet that provided its next generation firewall and endpoint security. So thanks to everybody. Have a great day.